Here is a next new concept is a domain and range of the trigonometric function. There are 6 trigonometric functions. We will start from the sine function. See here, we will see in the unit circle whose radius is 1 and the circle meet x-axis at A, B, C and D. A, B, C and D here. Suppose P is any point on the circle, draw a perpendicular PM, let the length of this be B and this OM is A. So the coordinate of point are A and B. Now let X be the angle made by OP with the OX in a anti-clockwise direction. Therefore, AOM is base and this OP is radius 1. So A upon 1 is cos X and B upon 1 perpendicular upon hypotenuse is sin X. So the value of A is cos X, value of B is sin X. Now we will see the values of sin X on the unit circle. See here at 0 degree, this is 0 degree, pi by 2, pi, 3 pi by 2 and so on. And as we put the values of X, the real numbers, the value or X will be 0, 1, sin X. The value of sin X 0, 1 and then 0, minus 1. And for all the real number, value remains between minus 1 and 1. So, first trigonometry, domain of sin X is R set of real numbers. Real numbers are positive and negative. If we take in this direction anti-clock, the values of X are positive real number. If we take the angle in clockwise direction, the angle is negative. In the direction, angle is negative. So here the values of X are negative. So we can put here the values of X, all the set of real numbers. So the domain becomes R, set of real number. Now range of sin X, we see here the values of sin X remains between 1 and minus 1. So the set of images is a closed interval minus 1 comma 1, or we can say minus 1 less than equal to sin X less than equal to 1. This is the range of the first trigonometric function sin X. Now see the second function cos X. Similarly, we can put all the values of X positive in the clockwise direction, anti-clockwise direction and negative in the clockwise direction. So domain of cos X is also R set of real numbers. And similarly, the values of cos X, see on the unit circle, here at 0 degree 1 and then as the angle go on increasing, when we reach at 90 degree, the value is 0 and at 180 degree or pi, it again minus 1 and then 0 at 3 pi by 2, 270 degree and then at 360 degree. After the complete revolution again we get value 1. And if we go on increasing the value of X, the value will repeat but it remains between minus 1 and 1. So range of cos X is also the closed interval 1, that is minus 1 less than equal to cos X less than equal to 1. This is the set of images, means the range of the trigonometric function cos X. Now we will see the domain of cosecant, say cosecant x, which is 1 upon sine x. Cosecant x is equal to 1 upon sine x. But cosecant x is defined only if sine x is see here, it should not be equal to 0, which is possible if x is not equal to integral multiple of pi, where n belong to n set of integers. At these angles this value is 0, so 1 upon 0 is undefined. It means we will reject all these values. So the domain of this function will be x such that x is the real number and x is not equal to n pi, where n is z. This is the domain of the cosecant x. Now see the range, set of range of cosecant x. See here, the function this 1 upon cosecant x is 1 upon sine x, and the range of this function is minus 1 upon minus 1 comma 1. So this will be the set, suppose y is the element, such that see here, cosecant x is 1 upon sine x, and values of sine x are between minus 1 and 1. These are minus 1, 1, when sine x is minus 1, the value is minus 1, and when value is 1 upon 1 means 1, but in between minus 1, these are the fraction. See here, suppose value is minus 1 upon 0.1, suppose, so it will be 10. If value is 1 upon 0.001, value will be 1000. If it is negative, suppose sine x is negative, means 1 upon 0.1 minus, then value will be minus 10, and so on, all these. So we can see the pattern that values are greater than either 1 or greater than 1. So y is greater than equal to 1, or y is less than equal to minus 1. Less than equal to minus 1. These are less than equal to minus 1. Where y is belonging to the set of real numbers. That we can see, this is a number line, this is minus 1, this is 1, and this is 0. So in this value, in this this is the if we put the value of x, these values, and x is not equal to n pi, at n pi, because it is 0, so we will reject only, we will put only the values of real number such that x is not equal to n pi. So then the value will value of cos x images will be greater than equal to 1 or less than equal to minus 1. This is the range of cosecant x. Now see the fourth trigonometry ratio, domain of secant x, which is 1 upon cos x. Now see, we can put any value of x, real number. X is any real number, but it should not be equal to 0. Secant x is defined only if cos x is not equal to 0, means x is not odd multiple of pi by 2. At pi by 2 the value is 0, so 1 upon 0 is not defined. So x is a real number, but x do not belong to 2n plus 1 pi by 2. So this is the domain of secant x. We can write like this. Now input is this. So range of secant x is y such that, again when we put value, this is the range value of cos x, we can put between the we will put the values of x from the domain, and value of cos x is -1 to 1 and all the fractions. So we will get like these value. So y will be greater than or equal to 1, or y will be less than or equal to -1, and y is a set of real numbers. So this is the range of this function secant x. Now we will see the domain of tan x. We know tan x is sine x upon cos x, and cos x should not be equal to 0, means x should not be equal to integral multiple of 2n plus 1 into pi by 2. So this should be kept in mind. So the domain of this function will be x such that x is a real number, but x not belong to integral multiple of 2n plus 1, or we can say x is not equal to 2n plus pi by 2, where n is a set of integers. X is not equal to odd multiple, because at this angle cos x will be 0, so sine x upon 0 is undefined. So all the real numbers except these are the domain of the tan x. Now range of tan x. Now if we put these values here, at sine 0, at x equal to 0, the value is 0. When x is a negative angle, this will be negative values of the real numbers, and when x is a positive angle, then it will be positive. But this is a fraction. Cos x is a fraction, cos x lies between -1 less than equal to x, cos x less than -1 less than equal to cos x less than equal to 1. We know these value. When we put the fraction here, we get a higher values, greater than 1. So we get all the real numbers. So range of this function is set of real numbers here, and in case of domain of cot x, we see what is cot x. Cot x is cos x upon sine x, and sine x should not be equal to 0 here. So x should not be equal to integral multiple of pi. Therefore, the domain of this function is a set x such that x belongs to the real numbers, but x should not be equal to integral multiple of pi, where n belong to z. And similarly, the range of cot x will be all the real number. We get 0 number here when we put all these real number here except integral multiple and pi, integral multiple of pi. Then we get all the positive real number, negative number, and 0. So range of function is set of images, means all the set of all the number, that is set of real numbers. So these are the domain and range of the all the trigonometric 6 trigonometric functions.